Chapter 12, Scalar Product and Vector Product. Part 3. In this video, I would like to introduce another product which is called vector product. I mentioned before, for the scalar product, we have some applications in physics, and in vector product, we also have some applications in physics, especially for example, torque. If you remember torque, which depends on the magnitude of the displacement and the force, and torque is a vector, so that we also want to have some special relationship to find the vector. So now we want to define what is what is vector product. Vector product, I want to emphasize that the main difference, and not only on the definition but also on the outcome. For the scalar product, if A dot B, if we have two vector, one is A, another is B, the final answer, which is a scalar, so which is called scalar product. How about vector product? We'll use cross to represent the relationship. So if I want to find A cross B, and not only the definition but also the outcome, this is a vector, so we'll call this as vector product. And let's see the definition. If A cross B, what is the magnitude of that vector, which is equal to magnitude A times magnitude B times sine theta, is not cosine theta. How about where is this vector? It is the orthogonal vector to both A and B. That means, let's see this example. If A cross B, A cross B, the direction of A cross B vector is this one. Remember, we'll use right hand rule to determine the directions. A cross B, the dimension is this one. How about B cross A? B cross A, use your right hand, rotate, and use your forefinger to rotate from B to A, and your thumb direction is pointing to this direction. So this is the direction of B cross A. And there are several properties you need to know. For example, if A cross B, which is equal to this is the magnitude, A times B times sine theta, times the direction, that means the unit vector of the direction of A cross B. We'll use this notation to represent the unit vector. How about A dot A? A dot A is equal to, because according to the definition, magnitude A squared sine 0 degree, sine 0 degree is equal to 0. So A cross A, help me to amend it. A cross A is equal to 0, and then I cross J is equal to K, J cross K is equal to I, and K cross I is equal to J. And remember, if we interchange that direction, vector J cross vector I, which is equal to the opposite direction of I cross J. So this is equal to negative K vector. Here are several properties we need to remember related to this vector product. I mentioned before, A cross A is equal to 0, and A cross B is equal to, it is because according to the definition, the magnitude of A cross B must be equal to the magnitude of B cross A, because also equal to magnitude A times magnitude B times sine theta. That theta is angle between these two vectors. If we change it, B cross A, only we have a negative sign, they are equal, which is equal to negative B cross A. If we have one scalar, okay, lambda time A cross B, you can either multiply the scalar to the first vector or second vector. We also have some distributive law. That means if A equals B plus C, remember the direction is very important. A is on the left hand side, so when you distribute it into the bracket, so A is on the left hand side. Similarly, okay, E is also, if we have zero vector, 0 equals A must be equal to 0 because magnitude and 0 vector is equal to 0. So 0 times magnitude A times sine theta. And the last one, okay, which is similar to the previous one, okay, if A equals B, what is the magnitude of this part? Okay, take square, which is equal to magnitude A square times magnitude B square minus A dot B all square. Okay, we can have more discussion on this one. Okay, let's see how can we apply the property to do example 12.9. Okay, proof. Okay, Q minus 3P cos P plus 3Q is equal to 10 Q cos P. Okay, let's see how to prove it. Okay, start from left hand side, because right hand side you cannot do anything. According to the distributive law, I know we can distribute it, but the direction is very important. That means similar to your junior form, Q cos P, and this one is very important. What's the values? Q cos VQ. Remember, if same vector, same direction vector, they cross together, which is equal to 0 because the angle between them is equal to 0. So plus 0, similarly this one also minus 0. The last part is minus 9P cos Q. Then, smart boys, girl, I guess you know how to prove which is equal to 10 Q cos P, because I know which is equal to plus 9 times Q cos P. So which is equal to right hand side. Done. For example 9, you may pause the video and then check your answer after you finish. Okay, find the magnitude of this part. The given information is A equals B, the magnitude is equal to 1 over 2. So let's see how can we simplify this. Just like the previous example, because A cos A is equal to 0, so which is equal to negative 4 A cos B, and then plus B cos A plus 0. Okay, because I know this one is equal to 0 and this one is equal to 0. So, and then simplify it, which is equal to negative 4 A cos B minus A cos B, which is equal to negative 5 A cos B. Because negative 5 is the only affect the magnitude of A cos B, so maybe you can take it out. But remember, magnitude must be positive, so 5 times magnitude of A cos B, which is equal to 5 over 2. Okay, second part. If we put the vector products on rectangular coordinate plane, that means x, y, z plane. So what's the result? Okay, I want to use example 12.10 to elaborate it. Okay, I want to use one stupid method to do it. I want to find A equals B. Later I will introduce how can we do it faster. Cos I minus 2j plus 2k. So, explain it. one by one. I cos I, remember I cos I is equal to 0. So 0, and then the second part is I cos j. If you remember, I cos j is equal to k, vector k. And then, how about this one, which is equal to plus 4. I cos k is equal to negative j. I don't want to expand it one by one, so maybe you can, I write down the answer for you. For example, this one, 3j times I, j times I is equal to negative k, and then j cos j is equal to 0, and j cos k is equal to I, so this is equal to 6i. By simplify the ijk, you can find the final answer. But we have a shortcut method to find a cross b, because I'm sure that you can find the a cross b by using the this idea, but maybe you have a lot of mistake. Then how can we find a cross b? We can make good use of matrix a cross b. If I want to find a cross b, I will put ijk and then the coefficient of ijk inside a matrix, inside a 3 by 3 matrix. The first row is ijk. How about the second row? The second row is the coefficient of I vector of vector j and vector a, so which is equal to 2 and 3 and negative 1. 1, negative 2 and 2. And we can use the leading, we can expand this matrix by using the first row. That means I vector I cross the minor matrix of this part. That means high this 2 row, and then this is the minor matrix. And remember, if you expand it by using this row, the operation of the second term is minus, because this is negative, okay? So negative, the minor matrix to negative 1 and 1 and 2, and this is j, and then the last part plus minor matrix and vector k. So the first term is equal to 6 minus 2 is equal to 4, and then 4 plus 1 is minus 5j, and then the last part is negative 7k. Okay, you can see they are equal. So maybe you can use this way to find a cross b. Remember, a vector and b vector must be in Cartesian coordinate plane. You may pause the video and do follow exercise 10. So this is the final answer. If a dot b, remember, you only need to consider I dot I and k dot k, because I dot j and I dot k is equal to 0, so it's equal to 1 and minus 6, which is equal to negative 5. And how about a cross b? Put it into a matrix, and then ijk, 1, 0, 3, and 1, 1, negative 2. Find the coefficient of this minus, find the coefficient of I hide this 2 rows, 0 and negative 3. And then hide this 2 is negative 2 minus 3, negative 5. And then because this is equal to negative, so simplify it, which is equal to positive 5. Last term, 1 and 0, so this is 1.